Okay, the second problem on the first worksheet says how many grams of chlorine gas must be reacted with an excessive amount of sodium iodide if you need to yield 10 grams of sodium chloride. Again, this is the second problem on the first worksheet. All right, so again, the first thing that we need to figure out is what elements or molecules we have in the problem, and then also what type of reaction we have so we know what products we have. All right, first thing in the problem, it says that how many grams of chlorine gas. We know that chlorine is one of the diatomic molecules because we need to memorize that. So you're going to write Cl2 as your first part of the chemical equation. And then it's going to be plus because that's how you write the chemical equation. And then it must be reacted with an excessive amount of sodium iodide. So we know that the other element or compound that we're dealing with is sodium iodide. So we go ahead and put sodium, which we know looking at the periodic chart is Na. And just from knowing it, we know that it's Na, and that we know that iodide is I. So we are going to put NaI. So now we need to figure out what the charges are so we know if they need any subscript. Sodium is over here on the metal side of the periodic chart. So, and it's in the first column, so we know that it is a +1. And then when we look over here at the iodine, we see that it's in the second to last chart for the nonmetals, so we know that it is a -1. So it's a +1 and a -1, so we know based on that there's no subscripts. And then also looking at the equation, we see that there is a single element reacting with a molecule or compound, so we know this is going to be a single replacement equation. So if you're not sure which element that the chlorine is going to replace, remember you can just look to see. So chlorine, you know that it is on the non-metal side of the periodic table, and we know, so we find it there, so it's on the non-metals. So let's see what else is over here. Oh, there's iodine, so we know that chlorine is going to be replacing iodine because they're both non-metals. And then so chlorine will replace iodine in the same part of the problem, or same part of the molecule that iodine was. So chlorine will be second to sodium. All right, so we have our products, which is chlorine gas, which is Cl2, because we know chlorine is a diatomic molecule. And then we had sodium iodide. Sodium was +1, iodine was -1, so neither one of them has a subscript. Excuse me.
Mr. Gray.
Excuse me.
Hey, Mr. Gray.
All right, so we know that those are no subscript. So now we can figure out the products. Oh, remember, before we figure out if a reaction can occur though, remember that we need to, sorry, I was distracted by the cat. We need to go to this reactivity sheet and find chlorine, which chlorine is oh, it's on the non-metal side. Duh. So really? It's over here.
You don't like
chlorine is the second highest, and iodine is on the bottom. So since chlorine is higher on the list than iodine, we know that, shh, are we really talking during my video? We know that chlorine is going to replace iodine in the equation. Now had it been sodium chloride and iodine was reacting, iodine is below chlorine, so iodine would not be reactive enough to remove chlorine. But since chlorine's on the top of the list, we know that it can react with the sodium iodine and bump the iodine out of there. Alright, so
You still almost just got something thrown at you.
we still videoing.
I know.
All right, so now we know that the chlorine is replacing the iodine. So we're gonna have sodium chlorine, and then plus iodine, which I'm pretty sure that iodine is a diatomic molecule. I really need to memorize this as well. So let me just look that up. I will get better at these videos. Let's see. Iodine, diatomic
You want some chicken on it?
molecule.
No.
Yes, so iodine is a diatomic. I thought so, but I didn't want to go. I was questioning myself. Okay, so we know that iodine, chlorine replaced iodine. So we know iodine is going to be by itself. And then remember that sodium is a +1 on the, and there's the cat again, on the periodic table. And then we know that iodine is in that second to last column as well. So we know that that is a -1 charge. So again, sodium, iodine is gonna, neither one's gonna have a subscript because sodium is +1 and iodine is -1. All right. So we have our equation as written, because again, this is +1, this is -1, this is +1, and this is -1. So, let me make sure. Yeah, so iodine and chlorine are both in the -1 columns. All right, so we're going to balance our equation now. Chlorine has 2 on this side. It does not have 2 on this side. So we are going to throw a 2 in front of sodium chloride. All right, so that balances that. But now we have 2 sodiums over here. So we're going to throw a 2 in front of the sodium iodine over there. So now we've got 2 chlorines, 2 chlorines, 2 sodiums, 2 sodiums, and then 2 iodines and 2 iodines. So we have a balanced equation now. You can make the chart if you want. I just did it quickly, so I'm trying to make these videos short, but if you need me to make the chart, I can. Just let me know. Alright, so we throw the 1 in there, we throw the 1 in there. I'll just go ahead and make the chart and show you what I did. So the chlorine was a diatomic molecule, so it had 2. Sodium had 1 initially, iodine had 1 initially, and then... Alright, so I went ahead and made the chart to show you. Chlorine had 2. Sodium had 1. So in order to balance the chlorine over here, we put a 2 over here. So we multiplied the sodium by 2 and the chlorine by 2. So then we had 2 chlorine, but then we also had 2 sodium. So we needed to get 2 sodium over here. So we put a 2 in front of the sodium iodine and then multiplied the iodine and the sodium by 2. Oh, and then that balances the iodine for us as well. So we have 2 of each on both sides. Alright, so now to do the equation part. Alright, so in the equation it says how many grams of chlorine gas must be reacted with an excess amount of sodium iodide if you need to yield 10 grams of sodium chloride. Alright, so we start with what we know. And we know that we have 10 grams of sodium chloride. Alright, what do we know about how else can we figure out grams of sodium chloride? We know that the molecular mass is grams of sodium chloride per 1 molecule of sodium chloride. So, since the 10 grams is on top, we're going to write the molecular mass down here so we can cancel out the grams. Let me use Joe's calculator. Alright, so we are dealing with sodium chloride, which we want to double check our chemical equation, make sure that there's no subscripts, make sure there's just one sodium and just one chloride, which there is. So we're going to, sodium is 22.99, and then chlorine is 35.45 plus 35.45. So that gives us a molecular mass of 58.44 grams of sodium chloride. I don't know why I'm writing it out and not putting the equation. Okay. And we know that that molecular mass is equal to 1 mole of sodium chloride. So we put 1 mole of NaCl on top. I don't know why I was writing it out. So we started with what we knew. We figured out the molecular mass for that compound. We know that that is 1 mole is equal to this many grams. So then we need to look at our ratio. We need to figure out how many moles of sodium chloride we have in the equation, which we go back up to our chemical equation. So we have 2 moles. So in this equation, we're going to put 2 moles down here. 2 moles of sodium chloride. So, like I said, we started out with this many grams. This was the molecular mass in grams. And for every, and this is how many grams are in 1 mole of sodium chloride. And then now we're going to do the comparing the moles to moles. There are 2 moles of sodium chloride in this equation. And then we are trying to find chlorine gas. So we need to figure out how many molecules of chlorine gas we have in here, which is just 1. So 1 would go on top here. 1 mole of chlorine gas. Alright, so then we need to figure out what the molecular mass of chlorine is, so how many grams in 1 mole of chlorine. Alright, so since we're trying to cancel out equations, we're going to put the 1 mole of chlorine gas on the bottom, since in the ratio it's on the top, because we want those to cancel out. Because we canceled out the grams of sodium chloride, we canceled out the grams of sodium chloride, or the moles of sodium chloride, and then now we're canceling out the moles of chlorine gas. So now we need to figure out what the molecular mass of chlorine gas is, which is 35.45. This is why it's important to know that it's a diatomic molecule, because we need to multiply that molecular mass by 2. So then we have 70.9 grams of chlorine gas. That is what we're trying to, that's what the question asks. It says how many grams of chlorine gas. So we've reached the end of our equation. So now we just multiply across the top, multiply across the bottom, and then divide the top by the bottom. So for the top, we have 709, and then for the bottom we have 58.44 times 2, we have 116.88, 709 divided by 116.88, which equals 6.07 grams of chlorine gas, and what we are looking for is chlorine gas, which is in the reactants. So since it's a reactant and not a product, we're not going to multiply it by 93%. So then that would just be our answer, 6.07 grams of chlorine gas.